Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. First of all, let me introduce myself. My name is Gilang Hakim, and I'm a master student in Industrial Pollution Control Engineering at Universitas Gadjah Mada. So, in this opportunity, I'd like to present about my research, which the title is The Potential of Imperata cylindrica for Phytomining and Soil Remediation of Red Mud Waste. So here is the outline of my presentation, which the outline of this presentation start with the introduction, followed by the research goals, research methodology, results and discussion, and end with a conclusion. Yeah, so let's jump to the introduction first. As we know, the red mud is a byproduct of bauxite processing that remains a challenge to this day. At least there are three main issues make red mud problematic. Red mud is produced in massive quantities, which by 2009, the total accumulation had reached 2.7 million tons, with annual addition around 120 million. Besides that, red mud has a very strong alkalinity, ranging from 10 to 13, and contains heavy metals such as chrome, mercury, arsenic, and lead as well. And in Indonesia, there are currently two operational alumina refineries that producing 1.3 million tons per year, with 12 more plants that are still under construction. And you can imagine if all the refineries start to operational normally, the estimated red mud production could reach around 31.5 million tons annually. And to mitigate its environmental impact, the government, through the Ministry of Energy and Mineral Resources, or we can say ESDM, is continuously developing innovation for red mud utilization. And in general, there are three main areas of red mud utilization that are widely studied. The first one is the valuable metal extraction, and the second one is the CO2 sequestration, and the last one is construction materials. But in this research, I just focus on the scope of valuable metal extraction. Despite its adverse impact that I mentioned before, red mud also offers several advantages, which is it contains valuable metals such as rare earth elements and other metals. And that's already a common method used for metal extraction, namely pyrometallurgy and acid leaching. But these are energy intensive, costly, generating acidic waste that could harm the environment. So phytomining offers an alternative method. This method using plants to extract metal from any substrate. So we use the plants to extract for any metals in the substrate. And surprisingly, this method not only extract the metals, but it can remediate soil by removing the heavy metals and improving the soil fertility after planting as well. And the previous studies have proven about phytomining's ability to accumulate valuable metals. In here, we can see this is the research of the Toknachini et al. In 2020. He found that the Odontarena cylindrica can accumulate up to 1,000 ppm of nickel. And similarly, Jelly et al., they show that the Chrapnoteres linearis, or Indonesia common as tanaman paku, could accumulate REE up to 2,700 ppm. But in my research, I tried to evaluate the ability of Imperata cylindrica to accumulate available metals and remediate the substrate. Thus, the outcome of this research include two outcomes. The first one is to evaluating metal accumulation in various parts of Imperata cylindrica. And the second one, or the last one, is to assess the soil health based on the total microbial parameters. Yeah, this research consists of two main scopes, actually, which is the first one is the pre-phytomining and the last one is the phytomining. And the pre-phytomining scope aims to determine the optimum composition of red mud and citric acid using response surface methodology. But however, I will not discuss about that in this presentation. And long story, after obtaining the optimum composition of red mud and citric acid, the phytomining is start. And in this step, initial characterization was performed to establish baseline data for red mud and soil. Samples were dried, ground to 100 mesh, and analyzed for organic carbon. And then for the nitrogen, phosphor, kalium content, and total microbes as well, while the XRF was used for major metal analysis. Additionally, 1 gram of fine red mud samples was digested using aquaregia and peroxide for 6 hours at 80 degrees Celsius. The digest then analyzed using ICP to determine its metal profile. Yeah, the next step was planting. Of course, this is the main step, I think. And in here, the red mud, soil, and citric acid were mixed according to the composition that we can see in this diagram. And Imperata cylindrica, or the plant, was planted in the mixture. Then the plants were watering daily with 150 milliliter of water, while the experiment is conducted in 35 days. And after planting, we move to the next step, which is the harvesting step. This step was done weekly. Yeah, we can harvest the plant in the day 7, 14, 20, 21, 28, and 35 days. And the plants were separated into 3 parts of the plant. The front into the roots, stems, and leaves. And then we can blend it. We blend it, and then the sample is ready for analyze. And the final step was post-planting analysis. I think this step was similar to the initial characterization, but the digestion process for plant samples only use aquaregia without any peroxide. And then after the analysis, the collected data were interpreted into some graph. So here, let's take a look at this picture. This is the effect of different harvesting time on the REE uptake. So in the study, the uptake of REE only happened in the roots part and not in the stems or leaf. And from this graph, we can see that 5 types of REE, which is the lanthanum, cerium, neodymium, scandium, and gadolinium, starting to be absorbed on day 28 with maximum uptake on day 35. And we can see here also that gadolinium showed the highest uptake, reaching almost 120 ppm. And this graph shows us the uptake profiles of major components at different harvesting time also. For iron and the titanium in the rows, both show an increasing trend, peaking on day 35 at 25,000 ppm and 8,800 ppm respectively. In the stems and leaf, for the iron uptake was less significant, I think, because the uptake is inconsistent, while the titanium showed promising absorption in its parts, even though the trend is inconsistent as well. This result suggests that titanium has good potential to be absorbed by Imperata cylindrica. And how about the soil fertility? Let's take a look here. Based on the total microbial parameters from day 7 to day 28, we can see from this graph which the microbial count in the planting medium decreased and fell below the initial level of red mud and soil. But alhamdulillah, surprisingly, on day 35, day 35, the microbial population increased significantly, surpassing the initial values with a count of 5.1 times to the 7th. And this indicates the soil microbes gradually adapted to the extreme condition caused by red mud over time. Yeah, so this is the conclusion of this research. To evaluate metals accumulation behavior, Imperata cylindrical plants have the ability to absorb several rare elements and major components such as the iron and the titanium. And for REE, the absorption only occurs in the root part and start on day 28 until day 35. And the REE with the highest absorption is the gadolinium with a value of almost 120 ppm. As for the major components, the titanium absorption occurs in all parts of the plant, and it implicates that Imperata cylindrica is so potential to absorb titanium. And to evaluate soil remediation behavior based on the total microparameters, phytomining on red mud also proved to be able to increase soil fertility based on the total microbial parameter. A significant increase in microbes began to occur in the final week with a final values of 5.1 times to 10 to 7th. Yeah, I think that's all from me. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.